All right, so let's talk about some decimals, and the first thing that we need to know is what the lady at the Verizon thing screwed up, which is simply place value. Where you put your place value is important. What the place value means is important. If we understand place value, we're much less likely to make a stupid mistake like that woman made. So if we look at this, before this section, we only had really whole numbers. We're going to add that decimal and put a whole bunch of numbers after that. Now, just like our numbers before the decimal, such as the 4, 5, 8, every number, every digit after the decimal has its own unique place value. By the way, do you remember what this place value is?
Ones.
Or ones.
Tens.
Good. So on and so forth, we go hundreds, thousands, 10,000s, 100,000s, then millions, and so on and so on. Remember doing that? We did it a while back, actually.
Yeah.
Now, when we go on the other side of the decimal, instead of the is, like ones, tens, hundreds, we have th. Can you yell? Yeah, we have the th.
I make the one with the
The only thing is, there's no such thing as once. There's ones, there's no such thing as once. Here's why. The first decimal right here, if you were talking about money, it would take 10 of these to make up $1, right?
Yeah.
If it takes 10 of those, we're going to call them tenths. There's no once. Once are ones. Okay, we already have that. We want tenths. So this place value right here starts with the tenths. Tenths. It all ends with a THS to the right of our decimal place, saying they are fractions of a dollar. Here's what the tenths says. It takes 10 of these to make up one whole. That's what it means. 10 of these to make up one whole. If we have 3 tenths right here, we need 7 more units to create a whole value for us if we're just talking about the tenths. Are you with me on that? The next one, it works very much like this side of the place value. Here we went ones, tens, hundreds. Well, there's no ones, but there's a tenths. The next one is, what do you think?
Hundreds.
Hundreds, you're right. Hundredths. Here's what hundredths mean. Hundredths mean it would take 100 of this place value to get one whole value. Just like if you talk about pennies. If you talk about 1 penny, it's 0.01. True? How many pennies are in a dollar?
100.
100. That's why it's 1/100th of a dollar. It takes 100 pennies to equal a dollar. That's what this place value does. So we have tenths, we have hundredths. What do you think the next one's going to be? Thousandths mean that it takes 1,000 of the value in this place value to reach 1. What that means for this, remember when that woman was talking about 0.002 cents? She was talking about 2,000ths of a cent. 2,000ths of a cent. It would take 1,000 of those to make 1 cent. She was converted and saying 1,000 of those would make $1. She was still talking about cents. She just didn't know it. The next one, likewise, you're going to get 10,000s or thousandths. Then we would get 100,000ths. We would get millions last. And again, here's what millionths mean. It means it would take 1,000,000 of these place values to equal just $1. So if you're talking about a millionth of a penny, it would take a million of those units to equal just 1 penny. If you're talking about a millionth of a dollar, that's different. Take a million of these units to equal $1. You guys see the difference there? Okay. Hey, which one's bigger? 62 or 117?
17.
Clearly 117. Why?
A larger number.
Because it's bigger. Sure. Because it's bigger. Now, here's another question. What's bigger? 62.000 or 117.0? What's bigger, 62.000 or 117.0? Wait a second, this has more zeros.
So,
Why?
because
This side is more.
So these are whole numbers, right? This isn't
Yes.
even part of this is part of a whole number. So if I'm comparing these numbers, do the zeros after the decimal really mean anything at the back end?
No.
So if you had someone who thought that, you'd be like, I'm gonna pay you $62.00000 a year. And you'd be like, dang man, I'm rich. That's awesome. If you thought those zeros meant something, right? But they don't.
Yeah.
That means you're getting $62 a year. You're gonna be broke. That's it. Right? Those zeros after the decimal place at the end of the number, they don't change the value of that number. They're just parts of the whole. So really, I mean, even though that's a very long number, because we have the decimal place, the only thing that's counting for us as far as money in the pocket is just this part. You're gonna have 558 whole dollars. The rest of this is just part of $1. It's a little more than 30 cents. That's it. Now, people struggle, people have a good time with this one, right? That's not a problem, because you have whole numbers there that's pretty easy to do. What I'm concerned with is, are you going to be able to find the difference between decimals? Such as, if I give you 0.693, .71. I need you to be able to figure out which one is bigger in that case. Where they have a decimal, there's no whole number, right? There's just a zero. That's why the zero's out there to show that you have a decimal somewhere. So here and here. The question is, which one is bigger? Is the .693 bigger or the .71 bigger?
0.71.
Okay, now why do you say that?
Because
You can put another zero on the top.
76.
Okay, so you could look at the first place value. That would be the tenths, right? Whatever has more tenths is a bigger number. Even though this one's a longer number, watch what you could do. You just recognize that the zero at the end of a decimal really doesn't do much, right? I could add zeros on here all day long. It's not going to change the value of that number. Couldn't I just add a zero here?
No.
Why not?
Oh, yeah, I agree.
So I could have 0.693 and 0.710. Are these the same values?
Yes.
Yes.
Is this the same as that?
Yes.
Definitely. Is this the same as that?
Yes.
Yes.
Which one's bigger now?
17.
It's easier to see when you make them the same length. So one way we can quickly see what decimal is bigger, make them the same length by adding zeros onto the end. Then you can just ignore that decimal. What number is bigger, 710 or 693?
So,
710. Make them the same length, then you can look at the actual length of the numbers as value. So add zeros until the place values are even. So add zeros. We're going to make the place values equal. Make the number of place values equal. Add zeros, make the number of place values equal. Then you can just compare the length of the actual values of those numbers. Essentially, you'd be multiplying by 1,000 here, and it's going to tell you that whatever number is bigger in this situation dictates whatever number is bigger in that situation. So if the .710 is bigger than .693, .71 is bigger than .693 as well. Raise your hand if you feel okay with this so far. Good. Well, we're going to continue our talk about decimals and the introduction to decimals by trying to put some numbers in order. Now, what we learned from last time, the last little bit from our first part of this section, is that if we want to determine which number is bigger according to decimals, we can add zeros onto the end of the number, and it really doesn't change the value. For instance, I said 62 and 62.000 really don't make a whole lot of difference. If you have $62 or $62.0, do you have any more when you do 62.0?
No.
You still have $62 in your pocket. That's the same idea. So we can add zeros onto the end of our decimal and not change the value of our number. What that allows us to do a lot of times is put numbers in order pretty easily. So let's go ahead and look at this example here. We've got 1.01, 1.2, 1.002, 1.1, and 1.12. We want to figure out what's the biggest to the smallest numbers. Now, right now it's a little confusing because we have lots of different lengths of numbers. One idea is let's make all these numbers the same length. So we'll add on zeros to make all of these the same length number. Our longest number, not necessarily our biggest number, but our longest number is 1.002. So I want to make this so it's point something something something. I want that length of 3. So in our first case, instead of 1.01, I can make it 1.010. Do we agree that's the same value? Yes, no?
Yes.
Okay. Then the 1.2, I can make that 1.200. Again, I'm trying to match up the length of all these numbers. 1.002, that's already the length that I want. I want the 3 decimal places. I don't need to add anything onto that number. 1.1, how many zeros do I need to add there?
2.
Okay. And then the 1.12, that's only missing 1 zero at the very end. You all right with that one?
Yes.
So we're just adding zeros at the end of it. It's not changing the value, but it's making it just a little bit easier to identify what's the biggest number, then the next biggest, and the next biggest. You see, the thing about it is, if we have all the numbers the same length, according to the decimal, we can look at the value of these numbers without the decimal, pretend it's not even there, and then pick out the biggest number. It's pretty easy as far as that goes. So when we look at this, we go, okay, instead of thinking of 1.01, think about it as 1,010. Think about it as 1,200, 1,002, 1,100, 1,120. Then you can pick out the biggest number and write that appropriately. Are you with me? So what's the biggest number that we have?
1.2.
Yeah, this one was. So we're going to write 1.2 first.
And then smallest to largest stuff?
Oh, did I say that?
Yeah.
Okay. Yeah, good call. I meant largest to smallest. I wrote smallest to largest. So let's stick with smallest to largest. What's the smallest number then?
1.002.
Yeah, we look at the smallest number here. That's going to translate to the smallest number here. Very good, 1.002. We got that one. Can you tell me after the 1.002, what number is just slightly bigger?
1.01.
Yeah, we look at the rest of these 4. This one's the next one. It's like 1,010. So we're going to put the 1.01. We're going to write what we signified this as.
Where are you crossing them out?
So I don't repeat them. What's the next smallest number?
1.12.
Which one? 1.2?
No, 1.12.
1.12?
No, 1.1.
This one's like 1,100. This one's like 1,120.
So the zeros don't matter, huh?
1.1.
At the very end, after the decimal, no. So we got 1.1. What's the next largest?
Are you writing in order?
1.1.
We already got the 1.1. So notice between these two numbers, which one is actually the smaller of these two?
1.1.
1.100 or 1.120? The 20 makes it big.
1.1.
This is a smaller one, that's why we had it. Then we're going to do the 1.12. And our last number, our largest number, is the 1.2. So by making the numbers the same length, we can pretty quickly identify what's the smallest, what's the largest, what's the next smallest, what's the next largest. I want you to try a couple on your own. I want you to tell me which of these is bigger on your own. Don't say it out loud. Tell me which one of those is bigger. Tell me which one of these is bigger. And lastly, I want you to put these numbers in order, from smallest to largest.
All of them?
Okay, so tell me which one's bigger here, which one's bigger here, and put these in order from smallest to largest. These are negatives. Which ones are bigger than smallest and largest? Looks like everyone's about done here. Hey, if we're going to do the 0.065 and the 0.802, one way we might figure out which one is the larger of the two numbers is to make them the same length by tacking on some zeros after the decimal place. So for instance, this has only 3 numbers behind our decimal place. This one's got 4. So if I add on a 0, 0.0650, 0.0802, this makes it just a little bit easier for us to compare these two numbers. So which one is bigger between our 0.0650 and our 0.0802? Which one's the bigger one?
802.
That one definitely is. If you want to compare place value by place value, that's also reasonable. So if you go, okay, here's my hundredths. I have 8 hundredths here and only 6 hundredths here. This is definitely the larger number. If I put the zeros so they're the same length, I can easily identify which one's bigger. You okay with that? Now, as far as this one goes, these are the same length already. We've got 0.25 and 0.27, negative 0.25 and negative 0.27. Since they're the same length already, what you're going to do is pretend there's no decimal there at all. Which number's bigger? Negative 25 or negative 27?
Negative 25.
Yeah, negative 25. So if negative 25 is bigger than negative 27, negative 0.25 is bigger than negative 0.27. How many people got both those right? Good, all right. Especially the negative one, that's important. Okay, next up. Wow, that's a lot of 3s. My goodness. Well, we better go start making those all the same length. So I know I've got 3.03. That's the longest number here. We have 2 decimal places, 2 decimal places, and 2 decimal places. So I'm going to leave these ones alone. However, when I get to the 0.3, what am I going to change the 0.3 into?
0.20.
0.30.
Good. And the 3.3 into what?
0.
So now they're all 3 numbers long. We have something in front of our decimal place and 2 numbers after in every single spot. That's what we want. Now it's going to be pretty easy to compare these numbers. We're going to go smallest to largest. What's the smallest number up here? If you ignore the decimal place, it's going to kind of tell you. This would be like 303. This would be like 33. This would be like 30. 330 or 3. Which one's the smallest of these numbers?
0.2.
This is the one. That's the smallest one. It's like 3. So writing smallest to largest, I'm going to translate that back into the number that we originally had. So 0.0 0.03. I cross it out because I don't want to get confused. I don't want to get confused with any of these numbers. I'm done with that one. I don't have to look at it anymore. After that, I pick the next smallest number. I look at these ones. What's the next smallest one?
3.3.
3.3.
This one?
No, it's the next.
Yes.
Okay. I'm going to write that, 0.3. What we started out with. Cross it out. What's the next one after that?
0.33.
Yeah, these have the whole number out front. Those are definitely bigger numbers. Cross it out. We got two more. What's next? 3.03 or 3.3?
0.03.
Yeah, that'd be like 303. This would be like 330. And lastly, we'll get the 3.3. Would you raise your hand if you okay telling which decimals are larger, smaller, and putting them in order? Yes, no? Okay, good deal. The next thing we're going to do, last thing for our section, we're going to refresh your memory on how to do rounding. Now, I got to tell you, the rounding rules are not going to change. Do you remember rounding from like our first chapter that we ever did in this class? We identified the place value. We looked at the digit to the right. If it was 5 or more, we did what?
Round it up.
If it was less than 5, we did what?
Just stay the same.
Did we go down or stay the same?
Just stay the same.
And then we followed it with zeros. True?
Yeah.
The only thing that changes about this is that we don't necessarily have to follow it with zeros, because the zeros after the decimal place don't really matter. They don't. So we're going to round the same exact way we did. The only thing you got to be good at, you got to know your place values, right? You got to know them very, very well. If you don't, well, then we're going to make some mistakes on this. So we're going to round the same way we did in the first chapter. We're going to identify the place value, look at the digit to the right, not all of them, just the digit to the right. That's going to let us know whether we round up or stay the same. And the rest of the numbers we omit. You either write zeros or you just don't write them at all. Are you ready to try some?
Sure.
I hope so. It's Friday. These guys should be a little excited today. Music started playing. I mean, that's exciting.
It's not Fraction Friday, though.
It's not fraction. It is. Technically, these are all fractions.
Okay.
Oh boy. Yeah, that's actually the last thing I'll show you in this section, is how to change from a fraction to a decimal. So we're going to round 6.9237 to the hundredths. To the hundredths. You got to be good at a couple things. First, knowing how to round in general. Second, knowing the place value. So we got to identify the hundredths. We're going to practice this with this number right now. Ladies and gentlemen, what digit is in the thousandths place?
3.
3.
Good, 3. What digit is in the ones?
6.
6 is in the ones. What's in the oneths?
9.
9.
The
There's no
oneths.
ones.
There's
There's
no
no
ones.
ones.
There's no trick question. There's no oneths. What's the 9 then?
Tens.
Tenths. What's the 2?
Hundreds.
Hundred.
What's the 7?
Hundred thousands.
10,000.
Tens, hundreds,
Hundred.
thousands, 10,000.
10 thousandths. 10 thousandths. So we'd have ones, no oneths. There's no such thing as oneths. We have tenths, hundredths, thousandths, 10 thousandths. It's hard to say that for me. It's just getting like a tongue twister. We're rounding to the hundredths. So the first thing you do, identify the place value we're rounding to. Again, what number's in the hundredths, please?
2.
2.
So we're going to underline the 2. How you round things. There's a refresher course for you. You look at the digit to the right. Not all the numbers, just the digit. That means the 3. If this number is 5 or more, you raise this. If this number is less than 5, you leave this alone. Are we going to raise the 2 up or leave the 2 alone?
Leave it alone.
So you're going to get 6.9.
2.
6.92.
Then what?
Get it up.
You can, if you want, put 0, 0. Do the zeros matter though?
No.
No.
Not really. After the decimal place, you can omit them. So with rounding with decimals, you can put 0, 0 if you want, or you can leave it without the 0, 0. It doesn't really matter. Some people like to put the 0, 0, signifying that it's a rounded number, that you rounded to that. Let's try 2 more. I'll give you a few to do on your own. Let's do 12.385. To the How about tenths? Tenths. Again, let's practice. Ladies and gentlemen, what digit is in the tens?
3.
The tens.
1.
When?
1 is in the
One.
tens. Z.
The 1.
What's in the tenths?
3.
3.
3's in the tenths. Yeah. You gotta be careful on the th and the z. Okay? The tens is a 1. The tenths signifies after the decimal place, that's the 3. So I'm going to identify the tenths. I'm looking at the, wait a minute, do I look at the digit to the right or the digit to the left?
Right.
Good, so I'm looking at the 8 or the 8-5?
8.
Just the 8, the 5 doesn't even matter. Okay, we're just looking at that digit. Am I going to move the 3 up or leave the 3 alone?
Yeah.
That's 5 or more, I'm going to move it up. I get 12 point, and you can put a 0, 0 or just leave it 12.4. This 8 rounded that 3 up 1 unit. Tenths. 3's in the tenths.
Why?
There's no such thing as ones.
Oh.
Remember, you gotta be really good at place value to get your rounding right. Really good at it. Okay, 0.46972 to the thousandths. The thousandths. Let's identify these place values. Everybody in here, what is this place value right here, the 4? What is that? Tenths, good. What is the 9?
Thousands.
Thousandths. What's the 7?
10,000.
10,000.
What's the 2?
100,000.
Which digit are we looking for?
Thousands.
That's the what now?
9.
Thousands.
That's the 9. Hey, watch carefully up here. Well, I had some concerns on your homework from the very first chapter when you did this. If we look at the 9 right now, that is the thousandths. We look at the digit to the right. The digit to the right is a 7.
Yeah.
Does a 7 say to move the 9 up?
Yes.
Where does the 9 go?
To the
0.
You can't do this. You can't go 0.461000.
You make the other number.
That doesn't work.
You make the 6. to
7.
Okay, so right now what happens
You make the 9.
is that
10, so it becomes
Good.
7.
this 7 has moved this number up 1. It's overloaded that place value. You can't put a 10 there, so we're going to put a 0 there, right?
Yes.
However, this right here is not accurate because even though you moved that up and became a 0, that carries over and the 6 becomes a 7. How many people understand why the 6 is now a 7 also? Good, so I didn't round this, I actually rounded this one, but it forced me to move that 6 to a 7. In this case, I am going to show the 0. You don't have to, but I did. Do you feel okay with the rounding?
Yes.
You want to try some on your own?
Yeah.
I'll give you 4 examples. I'm going to say that means to the. Okay, work independently. I want to make sure everyone can do this. Leonard. Okay, so some rounding stuff. Let's see what happens here. First thing you gotta do is, of course, identify the place value that we're dealing with. As far as our first number, what digit is in the thousandths place here?
7.
7.
Good, so we'll underline that. Are we going to move the 7 up or leave the 7 alone?
Move it up.
Why?
5 or greater.
So I get 0.938. Did you get 0.938?
Yes.
Good. Or 99380, that's fine as well. How about this one, the 10 thousandths? What number's in the 10 thousandths?
8.
Okay, here's where you got to be a little careful. You need to identify that we're really only looking at the digit to the right. Here's a common mistake a lot of people do when they're first learning rounding, or when they don't really understand it that well. A lot of people go like this. They go, oh, the 9 rounds the 4 to a 5, the 5 rounds the 8 to a 9. Can you do that?
No.
No. You're actually just looking at that digit, just the 4. So in this, are we going to move that 8 up or leave the 8 alone?
Leave it alone.
Yeah, we're done. I mean, we just do 3.6758. That's it. That's it. No rounding two numbers. It's just you look at that digit to the right. Now to the hundredths. 9's in the hundredths. We'll look at, and it might seem to you like I'm contradicting myself here that we don't round two numbers, but this one's forcing us to. You see, when we have the hundredths here, and that's a 6, it's 5 or more, it's going to round that 9 up. It was like our previous example. We're going to get 2 point, this changes to a 0, but because that changes to that 0, it's actually 10, that 10 moves over and makes that 5 into a 6, you get 2.60. Did you get 2.60?
Yes.
Or 2.6 is fine, that's good as well. How about the next one, the tens? What's in the tens?
4.
9.
Why not the 9?
That's not
That's
it.
not-
Ah, tricky. Am I asking for tens or tenths?
Tens.
So you got to be able to read that question appropriately, all right? So know where you're rounding. We're not rounding to the tenths here, otherwise I would have put tenths. I'm rounding to the tens. So does that 4 move up or stay the same?
Move up.
Move up.
Becomes a what?
5.
Can I just leave it 5 in this
No.
case?
No.
Put the 0, Lee.
So there's a difference between where the zeros are as far as the decimal is concerned. Here, this is a 5, yeah, but that has to change to a 0 because we haven't made it past our decimal place yet. So here we'd have 50. You can put 50.0 if you'd like, but you definitely need at least that 0 so you can find that you're at 50. I'm going to feel okay about the rounding. Okay, one more thing I gotta teach you before we do fractions to decimals and vice versa is simply how to say the numbers appropriately. There's a couple ways we can say decimals. We can do this number as 5.92. We could say that. We could say this one is -3.102 and just enunciate every different digit. But a lot of times you'll hear people say this: 5 and, -3 and, 458 and. That decimal stands for and, or and stands for that decimal. So whenever you hear or say the word and in mathematics, that means a decimal. That's why I was so clear when we said words the first time that you don't say this 458. If you said 458, it's inappropriate. This is 458. 458 would signify a decimal. Remember that from the very first time we learned numbers? I said, you can't say and. You're like, why not? Well, because and means a decimal. You said 458. What you're saying is 458 somethings. 58. What do you mean? Hundreds? Thousands? What are you talking about? So the and means a decimal. So we could say this 5.92, but the other way that we say this, you identify the last place value of your number. So in other words, what place value is that?
Hundreds.
Hundredths. Very good. You could say like this: 5 and 92 hundredths. That's another way to say it. 5.92 or 5 and 92 hundredths. You're saying the whole number, and means decimal, however many hundredths you have. Here there's 92 hundredths. Do you follow?
Or you like do word problems?
Well, you're saying them in words. I guess it's word problem. Here we could say -3 and what's the ending decimal place value here?
102 thousandths.
102 thousandths. Very good. This one would be said as 458. No, so I'm not saying 458. 458 and 2,197
10,000?
10 thousandths. That's how you'd say that appropriately. So we need to practice saying some of these. You'll have some homework. Just go through and say those in your head. Make sure you're pronouncing them properly. Okay, the last thing we get to talk about in this section. We can always change an ending, a discrete, which means a finite decimal, into a fraction, or any fraction into a decimal. So we're going to talk about how to do that. Fractions to decimals, or backwards. So we clearly have a fraction here. We get 43 over 100. Here's how you change a fraction into a decimal. If it's over 100 or 1,000. I'll teach you another way how to do this in general later on. But if we have something over 100 or 1,000, what you're going to do is what this signifies is how many parts you have out of 100 or out of whatever your denominator says. Here we've got 43 parts out of 100. That means we have 43 hundredths. So the idea is, however many zeros you have, that's how many you're going to pretend there's a decimal place. That's how many decimal places you move. You see, what you're trying to do is change a whole number into that many parts out of what your denominator is. So if we have hundredths, you're saying we have 43 individual parts of 100. This is 43 hundredths, and this is 43 hundredths. Does that make sense to you?
Yes.
So however many zeros you have is how many decimal places you move. We're moving already. So you started with 43. You said you had 2 zeros down here. What that means is that we're talking about parts of 100. That moves. This would be parts of 10. This would be parts of 100. Let's try another one. 501 parts of 1,000. How many zeros do I have?
3.
That means I'm going to move my decimal place 3 spots from the right. I'm going to pretend there's a decimal place over here. I'm going to move it 3 spots. And this equals, what's going to equal?
0.501.
Hey, notice something. We divided by 100. Our number ends in hundredths. We divided by 1,000, a whole number by 1,000. Our number ends in thousandths. That's what this is saying. It's saying the same thing. It's saying this is 501 parts out of 1,000. This is 501 parts out of 1,000. They say identically the same thing. It's just a different way to write them. So this is kind of weird for you. But every single time you ever see a fraction, you actually have a decimal. Every time you ever see a decimal, you actually have a fraction, unless that decimal is not repeating and not ending. Those are called irrationals. Like, have you ever heard of the number pi? Not the stuff you eat. It's just yummy. I'm very hungry right now. That sounds good, actually. But pi, like the 3.14159, and goes on forever. That you can't represent as a fraction. But if it's an ending decimal, you can represent that as a fraction. Speaking of, can we go backwards? Could you go the other way? I hope so. Let's try to write 0.2193 as a fraction. If we use the same method in reverse, all we've got to do is figure out how many decimal places we need to move this to make it a whole number. How many do we have to move it?
4.
So we'd go, okay, that's 1, 2, 3, 4 times to make that a whole number. What that means is I'm going to have 2,193 over something with 4 zeros at the end of it. We moved it 4 spots. That means 4 zeros. What's it have to be?
1,000. 10,000.
10,000. That's right. Hey, notice something else. What is this place value at?
10,000.
10 thousandths. What do we have it over? 10,000. This is parts out of 10,000. This is parts out of 10,000. So we can go backwards or forwards. Let's try a couple more here. I'm not going to show you the decimal place anymore. You can show that on your own paper. Can you tell me what the denominator of this fraction is going to be? Is it going to be 1, 10, 100, or 1,000? Which one?
100.
100. Why?
There's two
Can you
spots.
move it to?
2 spots means 2 zeros, or you think about it, it ends in the hundreds. You need this over 100. What's going to be on the top? 67 or 0.67?
67.
Good. Hey, could you change this one? Could you change that one into a decimal? 3 over 10,000?
Yeah.
Yes.
Well, wait a second. There's only one spot. I need to move it 1, 2, I need to move it 4 spots.
Just add zeros.
Okay, so I still move it 2, 3, 4. I just have to fill that in with zeros. So this is 0.0003. Notice how this is over 10,000. The number ends in the 10,000th spot. That has to match up. What about 3.49? Could you write that as a fraction? 3.49 is a fraction.
Yes.
Okay. Well, I know that the numerator is supposed to be 349, because I can't have a decimal on that fraction. It's going to be 349. But what's my denominator going to be, 100 or 1,000? What do you think?
100.
How many spots are you moving a decimal?
2.
2 spots, that means you have 2 zeros. It ends in the, even though that's a whole number out there, it still ends in the hundredths, doesn't it?
Yeah.
That's not the thousandths, that's the hundredths. You should have it over 100. Feel okay with it so far?
Yes.
Practice just a couple on your own. I'll give you 4 of them. They go real quick, and we'll move on to addition subtraction. So if they are decimals, I want you to write them as fractions. If they're fractions, I want you to write them as decimals. So we got 3 decimals to change into fractions and only 1 fraction to change into a decimal. And I also put some negatives up there. Are the negatives going to hold you back at all?
No.
Nah, they're just going to stick along with those problems. It's not going to really change it much. How about the 3.9? 3.9 should be 39 over what?
100.
So
39 over 10?
39, it's got to be a whole number, over how much?
10.
Not 100. You only moved it 1 spot. It should be 10. It ends in tenths. You should have it over 10. 0.125. I'm hoping you got 125 over 100. How many spots did you move it?
1,000.
How many spots did you move the decimal?
3.
How many zeros should you have then? That's going to be
1/8.
1/8. That's right, 1/8. You can reduce that. You actually can reduce that, and you should reduce that if you can. If you can reduce your fraction, do it. 25 goes into both those numbers. Actually, 125 goes into both those numbers. It goes in 1 time and 8 times. That actually does equal 1/8. So you can reduce these fractions. That's great. Works the same way. Okay, next up we've got negative 2.12. We need to get negative 212. Negative 212 is over 10, over 100, or over 1,000. What do you think? How much? 100.
100.
100. Because you only moved decimal 2 spots. It ends in the hundredths. You should have it over 100. And again, can you simplify that?
Yes.
Yes.
Yeah. What goes into that?
2.
More than 2.
Yeah.
2 goes into it, you would get,
5.
4 goes into it. 2 goes in it, you get 106, right? 2 goes into that, you get 53. Just 53 over 20, negative 53 over 20. If I've done that right, did I do that right? Okay. Last up, negative 350 over 1,000, I want to write that as a decimal. If I write negative 350 over 1,000 as a decimal, what's it going to be? Definitely negative, I'll give you that. So this says you move the decimal place, an imaginary decimal place, 1, 2, 3 spots for each 0.350. Or another way to write this, if you'd like to show the 0 up front, it's appropriate to write negative 0.350. Why people do that is so that you understand that that first 0 means there's a decimal place right after it. So you got to look at that and say, oh, I get it, I'm not going to misplace that decimal. Raise your hand if you feel okay with changing fractions to decimals and rounding.
What about, have you reduced it?
I did reduce it.
By what?
4.
4?
4 goes into both 212 and 100. Oh, you know what? I made a mistake there. That's supposed to be 25.
5 times 20, no?
Yeah, it should be 4. It should be 25. My bad. I asked you if I had it right. You guys don't have my back. You're supposed to have my back on this. My goodness. Come on, it's on videotape. I just made a mistake on videotape.
Edit.
I'm not going to edit that. I make mistakes all the time. Happens.
So you reduced it by what? 4?
4. Yeah. 53. If I did it right, you should be checking. Hope I did it right. Did I do it right?
Yes.
Okay, I think that was the only mistake that I had. I mean, I was testing you guys. You passed. All right, the next thing we're going to talk about in our class, we're going to talk about how to add and subtract decimals. What's very nice about this is we've already done the legwork, the groundwork for adding and subtracting things. We're just going to add on the fact that we have decimals, learn what to do in that situation, use our addition rules again, and we'll be done.